For calculus, this is a continuation of 3.5. I'll name it 3.5b for you. So again, we're looking at logs with different bases. So the derivative of log base b of x. And again, I tend to not memorize this. And if you just think of it as a problem like y equals log base b of x, you could actually use the change of base formula, which is why we teach you this in pre-calculus, natural log of x over natural log of b, because now just think about natural log of b is just a constant. So then the derivative of that is equal to 1 over natural log of b times 1 over x. And then just remember the chain rule. And that's exactly what this derivative is. 1 over natural log of b times 1 over x. And then again, chain rule. Write that out when it's applicable. So just like before, how we could sort of explain away certain things is the implied basis. So I'm going to do these in the same time. Is in previous lessons, we just said that this derivative was 1 over sine of 3x and then the chain rule. Well, if we do it using the rule above, it still works, because what you're looking at is it's 1 over natural log of its implied base of e times 1 over sine of 3x times the derivative of sine, which is cosine, leave 3x alone, times 3. And the whole premise of that is to get you to realize that natural log of e would cancel out. So your answer is just 3 cosine of 3x over sine of 3x. And if you remember from pre-calc, that's also equal to cotangent of 3x. So multiple choice might have the answer written like that, but the whole premise is to get you to understand that the rule still applies. So as we move forward and get some more difficult problems, is this problem, f prime of x is equal to, if it even helps you, just go ahead and rewrite it as natural log of 4x over natural log of 2. I don't know if that helps anybody. But what I'm looking at is 1 over natural log of 2, because that's a constant, times 1 over 4x times 4. And from there, what you should recognize is the 4's will cancel out. Okay, they do expect you to know this, and you would probably rewrite as 1 over x natural log of 2. Just so there's no confusion that it's not natural log of 2x. That's why we write the variable in front on these ones. So g of x, very similar. G prime of x is going to equal 1 over natural log of 3 times 1 over sine of x times the derivative of sine is cosine. And you'll probably see some answer keys that write this, that cosine over sine is cotangent. Just got to keep practicing here. So oops, that's h now. Just randomly changing letters on you. So we have h prime of x, that's equal to 1 over natural log of 5 times 1 over cosine of 3x. And then the derivative of cosine is negative sine. You leave 3x alone, but then you have to multiply by 3. So how I would write the answer, if you want my opinion, is I'd move that negative 3 in front, natural log of 5. Now I would think about how sine over cosine is equal to tangent of 3x. On the next one, don't forget there's an implied base of 10. So what we're looking at for p prime of x is 1 over the natural log of 10 times 1 over 2 to the 3x times the derivative of 2 to the 3x is natural log of 2 times 2 to the 3x times 3. So there's a lot going on there. What you actually should notice, this is sort of neat, that the 2 to the 3x's will cancel. And I'll explain why that should make sense in a second. And you could actually rewrite this change of base. Let me just write it for a second. Natural log of 2 over natural log of 10 times 3. Is that this is equal to 3 log base 10, which you don't have to write, of 2. Now, the reason why this should make perfect sense to you is because our rule for logs, let me go to black, is if you have a power in a log, you can move that power in front. So all you're looking at, let me extend the page, is p of x is actually just equal to 3x times log of 2. Now here's the thing. Do you know the derivative of x? Yeah. The derivative of x is just 1. I'm just going to write it off to the side here. 1 times. Everything else is just a constant. So you can just rewrite it as 3 log of 2 times 1. That's your final answer. So if you can find an easier way to do a problem, take advantage of it. That's why we spend time teaching you logs and all the law of logs and shortcuts, etc., etc. They will help you. So pause the video before I move on to the next page. And some more problems may remind you of the shortcut that this is to the 1/2 power. So k of x is actually equal to 1/2 log base 7 of x squared minus 1. Now you can't move this x squared in front because it's not the entire function. You can move the 1/2 in front because it was the entire function. So k prime of x is equal to 1 over, the 2 is still there, natural log of 7 times 1 over x squared minus 1 times the derivative of the inside, which is 2x. Now you should simplify when you can. For instance, those 2's would cancel. Thought I'd change colors, but I guess not. These 2's cancel. So we're looking at x over natural log of 7 and x squared minus 1. Q of x, we're throwing in a quotient rule inside of this, but don't be scared. Because it's 1 over natural log of 3 times you flip that, well, flipping that would be x minus 1 over 3x, and then times the chain rule, quotient rule, excuse me. It is a chain rule, but it is a quotient rule there. Derivative of the top, leave the bottom alone, minus the derivative of the bottom, leave the top alone, all over the denominator squared. Now, you can for sure cancel some things out. For instance, these x minus 1's would cancel. If you distribute this 3x in here, we're looking at 3x minus 3 minus 3x. Looks like those pieces will cancel, 3x minus 3x. So if I did my math correctly, we can actually cancel out a 3 as well. So you have negative 1 on top over x minus 1 natural log of 3. x minus 1 natural log of 3. And like I said, this 3 would cancel out with this 3. Now, just for the record, there's a faster way to do this. I'm not sure if you remember or if you would even notice that for q of x, you could have actually rewritten it as log base 3 of 3x minus log base 3 of x minus 1. And now if you did the derivative of that, isn't math just a beautiful thing? It's 1 over natural log of 3 times 1 over 3x times 3. Well, you can see some 3's cancel out there as well. Change colors. That will cancel. And then minus 1 over natural log of 3 times 1 over x minus 1 times 1, but you don't have to write that. So if you got the same denominator and things would cancel, this is equal to that green piece up there. But I'm going to box that one in because that's better. That's a better answer than what I have down here. So same thing goes for p of x. I would probably well, you got to be careful because it's just x squared right there. So let's just work it out. It's 1 over natural log of 2 times 1 over sine of x squared. The derivative of sine is cosine, and then the derivative of x squared is 2x. And as far as I would rewrite it, 2x over natural log of 2, and cosine over sine is cotangent of x squared. That's how I would write that answer. And right before your homework, we can throw in another problem that involves tangent. Well, let's practice some of these rules just to make sure we're clear that h of x is just equal to log base 2 of x minus log base 2 of 2x plus 1. Because if you have these shortcuts, you might as well use them. And I hope that makes sense. So then when you do the derivative, we're looking at 1 over natural log of 2 times 1 over x. And you don't have to do the chain rule because the derivative of x is just 1. Natural log of 2 times 1 over 2x plus 1, but then times 2. And what you need to do now is set that equation equal to 5/2. And again, let's just practice with the calculator and make sure that we, if we're going to be asked to use a calculator, we might as well use the calculator. So my point being, go back to the original problem, and this is actually saved from before. And don't forget these calculators do log base. If you go math and you scroll down, the A option is log base 2 of x over, I already forgot what it was, 2x plus 1. And instead of, let's say you mess this up for some reason, you don't want to even test it, you can see if this is the correct answer by typing it in, because you have to use your calculator anyway, and then we want to see where it equals 5/2. And if I'm being completely honest, we don't even care to see the blue curve, the original problem. We don't even care to see what the derivative looks like and where the derivative equals 5/2. So you could actually highlight and press enter on that equal so it won't even show up. And so now when I go to the graph, there you go. You can actually see that there's 2 values, which seems weird, but I guess it's okay because all we care about is that log a positive. So if x is a negative value and is super negative, it'll still work. So let's find both points of intersection so I can calculate. Intersect is the 5th option. And I'm going to find this point of intersection first. Oops, wrong button. Second, calculate, point of intersection. Enter, enter, enter. Looks like negative 0.842. But then also happens at second, calculate, intersect, move to the right, enter, 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 0.342. Alright, and I don't have an answer key, so I'm trusting that I did everything correct there, and you should be ready for the homework now.